Okay, so on your test, number 25, it says if the voltage phasor is 18 volts at 53 degrees, VC is 4 volts. So VC goes which direction? Down. That's 4 volts down. VL, we need to find, would go this way. And VR would go this way. We need to end up at 18 volts at 53 degrees. So what we need to do is we need to find the horizontal and vertical components of this. The horizontal component would be right here. That horizontal component, V horizontal, is going to be the 18 volt times the cosine of 53 degrees. $10.83 volts. That's the horizontal component. Which one of those can give you a horizontal component? The inductance or the resistance? Resistance. So the resistance is the only thing that can give you a horizontal component. The resistance is completely horizontal. So that is actually VR, 10.83 volts. The vertical component then here, the voltage vertical, must be the total voltage, 18 volts, times the sine of that angle of 53 degrees. $14.38 volts. So this is 14.38 here that we have to get to. But the capacitance has already taken us down by 4 volts. So how do we get, how much does the inductive voltage have to be to get us back up to there? Yeah, 14.38 plus 4. 18.38 volts. That's the inductive voltage. Okay, so for today, our new stuff, starting our new unit. This is unit 6, isn't it? Woohoo! Unit 6 deals with trig applications to finding areas. Some of these involve a lot of trig, some of these involve, just a little trig. Today's involves kind of a medium amount of trig. What we want to look at, what we want to talk about is the area of triangles. And we've talked quite a bit about the area of triangles. By the way, I put a worksheet out there. Hopefully everybody got one of those worksheets out there. That'll be your homework for today. And our first formula for the area of a triangle involved a right triangle like this. If I wanted to find its area, how did I find its area? What was the formula, first of all? Base times height, then divided by 2, or 1/2 base. Well, how do I know which one's the base and the height? First of all, does it matter which one's the base or the height? It doesn't matter which is which, but I do have to pick the right two. Of the 3 sides of that triangle, how do I know which 2 to use? When I find areas, the 2 dimensions I use have to have what relationship to each other? They have to be, or they have to form a right angle. They have to be perpendicular. So the 2 sides that are perpendicular are the 5 and the 12. They're the legs, and since this is a right triangle, they're the legs. So 5 times 12 or 12 times 5 really doesn't matter. Divided by 2 gives us 30 square feet. If it was not a right triangle, Yep. If it's not a right triangle, I have this 18 inches here. I'm going to tell you that's the base. Would knowing either of the other two sides help us at all? No, maybe, but not really. What do we really need to know is an altitude. An altitude goes from the vertex that's across from the base, opposite the base. So we know that's this vertex up here. And what do we know that it has to do with that base? Perpendicular, form a right angle. It has to come in perpendicular. So that's the dimension we want to know. An altitude always goes from the opposite vertex back to that base at a right angle. So if I tell you that that is 7 inches, how do I find this area? Not everybody at once. There we go. 18 times 7 divided by 2 is 63 inches square inches. What if we had this and we were told that this down here was 15 centimeters? We're going to use that as the base. Where would the altitude be? Well, it has to come from this vertex, doesn't it? It has to be perpendicular to that base, doesn't it? Well, that's one of the reasons, one of the differences between perpendicular and a right angle. To form a right angle, it actually has to touch the line. To be perpendicular, they don't actually have to intersect. To be perpendicular, I can actually project this base out here like this and draw this altitude down. It's still perpendicular to it. Even though they never actually touch and form a right angle, they still are perpendicular. One of the definitions of perpendicular is they vary in direction by 90 degrees, and those do vary in direction by 90 degrees. So if I know that that height is, oh, let's call it 8 centimeters, that might be a little bit out of scale. How am I going to find that area? (15 centimeters times 8 centimeters divided by 2, which of course gives us 60 centimeters squared. Your energy level is overwhelming today. Calm down a bit. Yeah, I know. I'll So in all of these, we either had to have a right angle in the triangle, or you had to have information that gave you that altitude that forms the right angle or perpendicular with the base. If we did not have a right angle, so let's say that this was 15 feet, 20 feet, and 25 feet. How would we find the area of that triangle? Remember something called Hero's formula from last semester? What was Hero's formula? Step 1 of Hero's formula was to find the perimeter. We find the perimeter by adding together the sides. 15 plus 20 plus 25 is 60 feet. What was step 2? Do you recall? F, which is the semi-perimeter. What's the semi-perimeter? The perimeter divided by 2. 60 divided by 2 is 30 feet. Then here comes the fun part, the formula. If we let the sides be sides A, B, and C, The area is the square root of S times S minus A times S minus B times S minus C. So that's going to be the square root of 30 times 30 minus 15 times 30 minus 20 times 30 minus 25. In other words, the square root of 30 times 15 times 10 times 5. Otherwise known as the square root of 2,000 or 22,500. Does that look right? Yeah, we'll see. Square root of 22,500 is 150 square feet. Is that what you got? So that's the area using Hero's formula. By the way, the fact that that came out to a number with no decimal tells us something about our triangle. That triangle is a right triangle. If it wasn't a right triangle, there would be a decimal here. Always. If the triangle is not a right triangle, the area will be a decimal. For Hero's formula, at least. So how would I know that this is a right triangle without going through that whole area? Pythagorean theorem. Which two sides would have to be the legs? The smaller ones. The hypotenuse would have to be the larger one. So if we tested 15 squared plus 20 squared, that's 225 plus 400, 625. What is 25 squared? 625. So since those are equal, that is a right triangle, and the right triangle has to be between the right angle has to be between the two smaller sides. Well, okay, so I cheated there a little bit. I used a right triangle. What if I don't have a right triangle? To be fair, I'm going to give you guys one to try, and this one won't be a right triangle. So we're going to call that 11 inches, 18 inches, and this 19 inches. Find the area using Hero's formula. So what's our step one? Perimeter. So 11 plus 19 plus 18 is 48. What do we find from there? Semi-perimeter, which is 48 divided by 2 is 24. And then square root of 24 times 24 minus 11 is 13 times 24 minus 18 is 6 times 24 minus 19 is 5. So second square root 24 times 13 times 5, 96.75. What's our units? Inches squared. Now, somebody mentioned that we could find an angle here if we wanted to, couldn't we? We can actually find any of those angles. The one I would actually prefer to find is usually the largest angle, the one opposite the largest side. We can do that using our law of cosines. So this would say that 19 squared equals 11 squared plus 18 squared minus 2 times 11 times 18 times the cosine. I'll call that angle C. And I could solve for C. I get the cosine of C is 0.212121. So my inverse cosine is that C is 77.75 degrees. Well, if I knew that angle, how would it help us find the area? I still need an altitude. Knowing the angles doesn't help us really, unless we know an altitude. Well, but that angle can help us find an altitude. Let's use the 18 as the base. The altitude has to go from the opposite vertex, that would be this vertex, and it has to be perpendicular, form a right angle. That would be right here. What that just created for us is a right triangle here. What we know about that right triangle is that this is a right angle, this side is 11, this angle here is 77.75 degrees, and that this is the altitude of our triangle. To find that altitude, we would use a sine because that's the opposite side and this is the hypotenuse. Sine of 77.75 equals that altitude over the hypotenuse of 11. Well, if I'm going to solve that, what am I going to end up multiplying? Those two, right? So the altitude ends up being just 11 times the sine of 77.75 degrees. (10.75 units, inches). So the area would be that altitude times the base of 18 divided by 2, which is 96.75, which is what we had. We get the same result. Let's put this in general terms. The altitude can be found by just doing this side times the sine of this angle. So what that means is if I have a triangle where I have angles A, B, and C and sides A, B, and C, if I know side A and side B and angle C, that's the same information we needed for the law of cosines, right? Two sides and the angle between it. The area of that triangle is going to be the base, which is B, times the altitude, which was A times the sine of C, divided by 2. Now we can rearrange that as A times B times the sine of C over 2. But it's going to work the same either way. So anytime we have a triangle where we know two sides and the angle in between them, we can find its area. So how do I find the area of this triangle? 22 times 20 times the sine of 33 over 2. (119.82). What's my units? Inches squared, square inches. You get confused, Jordan? I'm gonna have you guys try. Find the area of that triangle. So where do we start? Eight times 25 times sine of 25 degrees over 2. So 42.26. Those are in feet, so that's feet squared, square feet. What do you think? Not bad? Please more. I'm going to give you this one. Find the area of that for me. Okay, so for this one, I'm just going to label it for ease of reference. What I really need is this angle up here. That's the angle between my sides. Unfortunately, I can't find that angle directly. I have my 15 over the sine of 41 degrees. My 16 would be over the sine of B. So that's not the angle I want, but if I know it, I can find angle C by just subtracting. So I'm going to cross multiply and divide here. Sine of 41 times 16 divided by 50. And then I'm going to do inverse sine. 44.41 degrees. Which makes this one up here 94.59 degrees. Very good. Now I can find the area 16 times 15 times the sine of 94.59 degrees over 2. $119.62. Those are in inches, so that'll be inches squared. What you think? Good stuff? Okay. How about this? Oops, come on now. Parallelogram. I'll tell you this side here is 12 inches, this side is 15 inches, and this angle is 50 degrees. Well, I could cut it across here and have a triangle, couldn't I? What do I know about this triangle and that triangle? They're the same. I can draw it because it's parallelogram. So the area here would just be 12 times 15 times the sine of 50. And I don't need to divide by 2. I could divide by 2 and then multiply by 2, but it kind of cancels out, doesn't it? So 137.89. That's inches squared. What if you were told we have 12 by 15, but we're told that angle is 130 degrees? Well, I still find that area, can't I? Because I can divide it this way. What's this side here? 15. So that area will be 12 times 15 times sine of 130 degrees. I didn't even have to punch that in the calculator. How did I know that was 137.89? Parallelogram, these angles here have to be supplementary. This is 130 degrees. They're the same parallelogram. How does it work out that it doesn't matter whether I use 50 degrees or 130 degrees? Yeah. Because those are supplements, sine of 50 is 0.766. Sine of 130 is 0.766. They're the same. Okay. You guys have a worksheet in front of you that I gave you. That is your homework for tomorrow. I want you guys to do as much of that as you can. There's actually some on the back that are kind of challenging. I'll let you guys have our last 16 minutes. Yeah. Carve them up into triangles and find angles. Once you know trig, it's amazing how much easier the geometry becomes. Yep.